Hello, everyone, and welcome to the 2026 training webinar on permeable pavement systems for stormwater compliance and long-term performance. Hosted by Monterey C, also known as the Monterey Regional Stormwater Management Program, we affectionately call it Mr. SWIMP, which is comprised of the cities of Carmel by the Sea, Delray Oaks, Monterey, Pacific Grove, Sand City, and Seaside, and the County of Monterey. The group works collaboratively to manage stormwater quality across these jurisdictions and coordinates regional efforts to address pollution entering storm drains. Our presentation will be 30 to 35 minutes, followed by a question and answer period. We will take questions during the presentations, so please use the Q&A feature on the webinar to submit your questions, and our presenters will respond as we go along. And we will always have questions at the end as well. So our first presenter is Santiago Ramirez. He is the supply sales manager at Granite Rock Supply. Chago has been with Granite Rock for 15 years this July, 8 years of which he was at the quarry in Aromas in the logistics department. He transitioned into sales for supply for 2 years and then moved up into management, where he has been for the last 4 years. Our second presenter is Shari Carlett. She is a public works project manager with the city of Carmel by the Sea. Shari is serving as the acting capital program manager for the city of Carmel. She holds bachelor's and master's degrees in civil engineering and has over 20 years of experience with Bay Area public agencies, including the delivery of the award-winning Southgate Green Street pilot project in Santa Clara County. So Chago will start us off, and thanks so much for joining us. Take it away, Chago.
Good afternoon, everybody. Let's get this thing going here. Today, we're going to be talking about permeable paving solutions. And we'll dive into 3 different categories, 3 different jobs. We're going to start with, if I can get the slide in there. We'll talk on porous asphalt, pervious concrete, and permeable pavers. We're going to start with asphalt today. I'll talk about the good, the bad, and everything in between. Asphalt is kind of limited in our ability to provide here in this area, but there's a common theme with all 3 applications. It's all about the base, and I can't stress how important and what that means to these projects performing the way they're intended to. Without the correct materials being laid out ahead of time, or the proper dig out, proper placement of base, and the proper materials, none of these systems will perform as they're supposed to. What we're looking for is that ASTM number 57, also known as the 3/4 drain run. This allows for all these applications to do what they're intended to. Porous asphalt, quick definition there, is a pavement that consists of porous asphalt surface with an underlying aggregate reservoir, your base, that temporarily stores rainwater runoff before it passes through the natural subsoil. This system replaces traditional non-permeable pavement, allowing to have built-in stormwater management systems. Very common in LID projects, which are low impact development. This picture here shows you the difference there. You can see the water sits on the surface of the traditional asphalt, and you got your porous asphalt to your right there. All the water is hanging out in the catch system, or losing the name. Very different in application. This graphic here shows how to do it, right? It starts with an uncompacted subgrade. Typically, you're putting down some type of fabric. Depending on the application, it goes from just a filter fabric, but it's got to be non-woven. It's got to allow for that water to come through it. And then what you're building there with your natural stone is a reservoir, somewhere where the water can hang out as it finds its way back into that uncompacted subgrade. Typically, you're using 1.5-inch drain rock in some applications, and then you're coming in with your number 57, which is the 3/4 drain, and then you have your asphalt application on top. Depending on how much traffic and the weight of the traffic, you're going to go from 2.5 inches minimum to 6 inches, and you can continue going up just based on the rating that you're trying to accomplish. Some of the advantages include reduces the site runoff. So your water finds its way into the ground. It acts as a water quality treatment, so it serves as a filter for the water. It reduces peak runoff of volume and velocity, and it requires less need for curbing and stormwater. Helps with traction in slippery conditions, and it supports sustainable lead goals, which are a big thing around here. Some of the limitations: it's not very suitable for high traffic. It reduces effectiveness if clogged. Maintenance. You'll hear maintenance. It's going to come up 3 different times here. A lot of the limitations are very similar on these applications, but it requires special equipment. You can't go in with a regular sweeper. You need a high-powered vacuum. Material availability. Reason I'm going through this one a little bit faster than I should is because the nearest plant to be able to provide that product is in Redwood City. It's one of our facilities. And by the time it comes down here, the workability, it's just not there. You have so much time to actually work with the material. So being that it would come out of Redwood City, it's very limited in our ability to perform that project. The installers, it requires a special type of installer. They have to be certified, and there is not a lot of them in the area. Even up north, there's a few. That brings us over into pervious concrete. Very similar. A lot of the things that I'll talk about, they kind of go lateral with each other. They're very similar. Pervious concrete is a cement-based concrete product that has porous structure that allows rainwater to pass directly through the pavement and into the soil naturally. This detail here shows you the application, and there's a trap here that I want to speak on because it is very, very common these days. You start with a filter fabric. A 180N is just a very thick filter fabric. This part here, your class 2 permeable aggregate compacted to 95%, and then it shows 6 inches of pervious concrete. We continue to see this very common. That class 2 permeable is very different than the ASTM number 57. Class 2 permeable consists of 3/4 rock, and it's blended with our concrete sand, which is a wash sand that's free of fines, and you can achieve optimal compaction. Very similar to base rock, but it still allows for the water to run through it, but it does not have the voids that these applications require. You want up to 40% voids in your system, and you're creating a place for the water to live as it finds its way back into the ground. The class 2 permeable, it allows for drainage, but it doesn't have the room that you need to hold one of those stormwater systems. When you get a lot of water at once, you're going to see the pooling if that class 2 perm is used. It's a very common misconception here. I think it works and you can probably get away with it, and the system will work, but it is not doing everything that you're putting all that money into building. You want to use the number 57. So if you ever see that class 2 perm called out on a detail, my suggestion is that you question it. You get with that designer, you ask a few questions, and then knowing about the number 57 and the why will help make that determination where they can change that. But it's very important. And you see it a lot. This is actually from a bid request that I received a few weeks back, and we had that same conversation. We quote both products, but the idea for this to be successful, you want the voids in the system. Some of the advantages: it meets stormwater management and first flush pollution prevention criteria, reduces or eliminates stormwater sewer tie-ins, reduces grading, reduces time and expense for construction and engineering. It has a long lifespan, up to 30 years, north of 30 years, and they can put a bunch of colors on it. There's a list of 50 different colors you can use, and you can do a lot of things there. Some of the limitations: it's not suitable for high traffic. You see this again. It's reduced effectiveness if clogged. That maintenance will come up again. The high power vacuum is required. The availability: we can make this product. We have plants locally in Seaside where you can get this product, but the installer is what you're gonna run into. There is not very many capable, and you need capable for this material to do what it's supposed to. Not every concrete guy can come off into one of these projects and do the work. One of my counterparts here shared a story with me, and he said, if you see one of your finishers getting out of the truck with a trowel in his hand, you may run into some issues there. It is not a troweled product. You need the material to stay porous, and the more you work with it, the less effectiveness you're gonna get out of it. Another thing is it has very little workable time. You have 90 minutes from the time it gets into the truck to the job site to lay it out. So you're doing sections at a time. If you got a big project, a lot of square feet, you're gonna have to cut out maybe a 10 by 10 square or 10 by 20, and you're gonna work days at a time. So it adds cost, it adds time to open your project back up. We'll get into permeable pavers, my favorite. Permeable pavers are sustainable, eco-friendly paving stones designed to allow stormwater to infiltrate through the joints into the ground, reducing runoff and flooding. Same thing, I said it a little differently. This design shows how you would build this project. Same thing, you have your uncompacted subsoil, some kind of geotextile, a filter fabric. This calls out for number 2 stone, which is an 1.5-inch drain rock. Your base layer is your number 57, back to that 3/4 drain rock. And then above that, you have the number 8, which is a 3/8 material. These work in conjunction. They bind into each other. You're actually compacting them down. They bind, and it creates your area for the water to hang out in. You have the paver on top of that, right? Depending on how much weight you plan on having on a project is how much you have to dig. Goes back to that base slide at the beginning. It's all about the base. So part of that design needs to really reflect on what kind of traffic is going to be on this project. Some of the advantages there are similar. You'll see it over again. Stormwater management reduces or eliminates stormwater sewer tie-ins, improves the water quality, that it's very available material and the contractors. It doesn't require any special certifications to put on the ground. Anybody that can do pavers can typically do a permeable paver job. You always find that there's some that are more experienced in it, but they are very accessible. And one of the biggest advantages is your access to the subsurface. If you have a pipe, if you have water, if you have something going on underneath that project, if something fails, you can pull this material up, set it to the side, and put it back in. You're not cutting anything. You're able to reuse the material that you paid for once already. You may have to change your base up, but you're able to reuse that top layer of material, which is typically the expensive part of the project on top of labor. And one of the big things that I'll harp on is the appearance. Out of the 3, I really think that pavers look the best. Some of the limitations here. I had to really think about this one because I might be a paver salesman at heart. But the install time, it requires some skill to put on the ground. Same with all 3. They really do, but you may spend a little bit more time on the project, which adds labor cost. The envy that you'll have to deal with from your neighbors, if you're at a home, your business partners, they just look the best. They're very nice. I think they finish very well. And the maintenance, same thing. As your joints get clogged, you have to use proper equipment. With this, if you can use the sweepers, you can use the vacuums. It's very easy, more standard product, but the maintenance will revolve around re-adding your joint material, which is a tiny ASTM number 9, small joint rock. Eventually, season after season, you may have to come back and add it again, which is not very difficult. Throw it on the ground, you sweep it into the joint, and you're done there. So, but all three of them require maintenance. Stanford did a test be in their bus parking lot some years back when these three uh, applications were coming into the world, and they did a test: porous asphalt, porous concrete, permeable pavers, and the universal. What they found is that they all work very well, but they all require maintenance, all three of them. And that is the truth behind this. That I can't stress that enough. There is going to be, it's not plug and play like we're used to with asphalt and concrete. Some of the limitations with these also, with the asphalt and the concrete, you can't slurry seal them, you can't seal them, you have to leave them exposed. So there's no going back and making them look nice again, like you would do with asphalt. Our comprehensive strength and flow rating. Pavers are very strong. Since they're smaller, they don't bear a lot of weight in each unit. So it goes up to about 8,000 PSI. Very strong. The infiltration rate is about 300 to 1,000 inches per hour. Pervious concrete, their comprehensive strength is about, depending on how much you put down, it goes from 500 to 4,000. So it can get very strong also. And that flows at about 480 inches per hour. I did add some pictures here because I think I may have tried to sell the pavers a little too hard, but I wanted to give some credit where credit's due. These pictures come from David Ligori. He's the president of Bay Area Pervious Concrete. He's one of the few that is set up to do this kind of work in our area. These are pictures of some of the work that he's put out. Very nice. Kind of shows what it looks like when it's done and done right. I did a quick cost analysis, and I separated the material, and then I gave an all-in price, and I checked this with a few contractors in the area. Pervious concrete is going to run you about 220 to 230 a yard, just your material. If you were to get a bid from a contractor, they would tell you all in, you're about $45 to $50 a square foot. For the pavers, the paver itself is about $550 to $650 a square foot. All in on the job, it's about 35 to 40 to perform that work. And it's going to vary based on the area. I think one of the things to really keep in mind is that you have to dig down further to build this type of work. You're not cutting out 4 inches. You're not cutting out 8. You're cutting out 10 to 14 inches. And getting rid of dirt in this area has become very, very difficult. So that's just something to keep in mind. If you run into something that is potentially contaminated from whatever reason, it's very hard to get rid of that soil. So these costs will vary based on where you can take the soil, if you can take the soil out, and how much testing is required to start your project there. So this is just kind of it gives you an idea of where you land on this. That's all I had. That's my contact info if anybody has any questions.
We do have 2 questions. The first is, I understand that there are permeable pavement systems in which the paver itself is pervious. Do you have experience with these systems, and do you know if they function better than, or at least as well as, traditional permeable paver systems where infiltration occurs in the gaps between the pavers?
Yes, we are familiar with that. Same base system. You still have to do your base, but they perform well, but they are more prone to clogging. Similar to the pervious concrete, it's porous enough to allow the water to run through it, but it is not going to capture the runoff like the traditional joint pavers. It's not going to get you there. You're going to lose some of that water. It's not going to find its way into your catch system. They do perform, they're called hydroflow pavers, and they're actually manufactured locally. But you'll run into performance issues sooner than you would with the traditional joint pavers, because as dirt finds its way into the face of that material, it's just not going to perform as well sooner than not.
Thank you. So our second question, do you have any specific recommendations for the edge condition around a permeable paver system? For example, is a concrete band always recommended, or can permeable pavers be installed adjacent to asphalt pavements?
It can be installed adjacent, but you do want to separate the two, right? With the asphalt, you're going to have a base layer underneath there. The last thing you want to do is have water going into that and coming back in. You're gonna hurt the performance of the paver, but also you're gonna promote that area to fall in. You're gonna undermine your base on the asphalt potentially. So you can do them up to each other, but you do want to create some form of separation, whether it be fabric, whether it be a concrete band. You do want to keep that separate, but they can go up against each other.
So we do have, thank you. We have another question. Can you talk to the advantages and disadvantages of using a hybrid system, HMA drive aisle draining to pervious parking area?
I think I'm gonna take a shot at this one. I think it's all about the design. If you have a sloped driveway that you want to use asphalt on, and you build your permeable area underneath that, you're still gonna accomplish everything that you're trying to do. Catch the water down below, and you'll have your asphalt driveway if you prefer that up top. I would say it's all about the design and what you're trying to accomplish.
Thank you. Another question. Can you compare maintenance frequency between the three options? Which one tends to clog quicker? Obviously, areas with higher sediment will need more maintenance, but pretend you are within a normal urbanized area of Monterey County.
Good question there. I would say the more porous, the more maintenance. So your asphalt and your concrete, they have those bigger joints up top. That's going to require more maintenance. The pavers are, you're only worried about the joint, which is about 3/8, versus the concrete and the asphalt are going to have pores throughout the whole surface of the project. I would lean towards the concrete and asphalt are going to clog quicker on you. They're going to require more maintenance.
Thank you. Next question. Have you seen this material used in paved basketball courts or similar where surface texture is more sensitive?
I would not use probably any of them on that surface. I don't play basketball, but if you fall on any of these, you're gonna leave there like you fell on a cheese grater. So the surface, and there is things that they can do. They can come in and actually sand the finishes and make it smooth to where it's not so rough. I would stay away from all three of these in something where people are going to be running on and riding their bikes on, scootering. It just makes for it's going to hurt.
Thank you. Our next presenter is Shari, and we will have her get going and share her presentation.
Hi everyone, my name is Shari Carlette. I work for the city of Carmel. Um, and today I'll be presenting a little bit more of the example projects for the permeable pavement system. I'm gonna be focusing on permeable pavers because that's mostly my experience, and those are projects that I worked on, and also, other projects that I kind of touched on. So on the first slide, so Chago has discussed impermeable pavers, pervious concrete, and porous asphalt, but my focus is going to be on permeable paver, and this particular one is the hydroflow technology pavers. So the material itself is actually a permeable or porous material. So when you put water on it, the water actually will infiltrate through that, and then the same thing, it will go through the different layers of um, I guess like permeable materials underneath or the subgrade. As an example here, this is what we use in one of our projects in Palo Alto. So this is a hydroflow paver. It is a universal profile with a herringbone pattern that we've used out there. And the colors is Santa Barbara 10. And then, as discussed earlier, the underlying layers are open graded sub-base layers. And particularly for this project, we did have an underdrain because there are some, the soil there does not have a high infiltration rate. So we had this infiltration column until we reach the more pervious sublayer of the soil, of the existing soil. So next, I just want to present to you one of the projects that I've worked on. It's actually one of the first Green Street pilot project in the Bay Area, which was part of the MRP permit for the Bay Area. This is the Southgate Neighborhood Green Street project. So basically, this project had issues on local drainage and also stormwater quality issues. And we also addressed elements of the bicycle and pedestrians transportation plan to enhance traffic calming and pedestrian safety. So the key elements of the project, the existing conditions are this neighborhood had narrow streets and had on-street parking on both sides. So that's one of the hurdles that we had to deal with. And so a couple of the project elements included about 3,000 biotreatment areas. And we also use under drains and infiltration columns in there. Another one, which is the primary, discussion for this PowerPoint presentation, is permeable pavers. So we use them in crosswalks and walkways. Then, other designs included planters and biotreatment designs. We also did include new storm drain inlets and pipeline installed as overflows, both for the bioretentions as well as these permeable crosswalks and walkways. So as you can see in here in the photo, basically the intersection in here has been, has been improved using the hydroflow permeable pavers. And there's the band in there. So you can see, you asked earlier, there are concrete bands in here to restrict movement with the permeable pavers. And obviously it's, like the bike is just right there. It's one of the bike element designed to for this project. Lessons learned. So we did encounter a couple of issues while we were working on these projects. We had to deal with utilities, existing trees, and flatter grades constraints for the biotreatment design. But then both for the biotreatment and the permeable paver, we had to reduce some aggregate depths because there were some storm drain conflicts there. And then to address this, this was the first time that a green infrastructure was being built into this city. So we had to do a lot of community outreach to improve the design, and also we had to address some issues on rideability concerns because you're putting pavers out in the street. So they had concerns of that getting uplifted, and then also issues on parking, but that's more particular for the bioretentions. Then we also had to do coordination with the city arborists and other city projects. Potholing was an important key because we needed to do utility relocations. And this project actually does include the sand layers underneath the permeable pavers, and it helped with treatment, grading, and protect groundwater. So again, there were concrete bands to prevent paver movement.
Shari, we have a question at this point, if you're able to take it.
Okay.
The question is, what traffic index was used for these streets? How did the section thickness of the paver section compare to a normal HMA section?
You know what, to be honest, I don't remember the that information, but this is a neighborhood street, so we were really expecting the biggest load that we were expecting in here are really for trash trucks, the trash trucks as well as emergency vehicles. So those loads were included in the calculation, especially for putting permeable paver on the street. But this is not like a high volume, large, equipment kind of road. So yes, so basically it's more of a neighborhood kind of streets that we were working on.
Thank you. We do have another at this point. Have there been any damaged pavers or replacements since the project finished?
Yes, so I mean I don't work there anymore, right? But what we actually did, because this was a pilot project, it was the first pilot project for the Bay Area. We did a pilot testing at the yard. So we did it for about 6 months. And I'm sorry, the question was.
Were there any damaged pavers or replacements since it finished?
Yes, so there were. I mean, we did a 2-year monitoring for this one. So at one point, there were some areas that were sagging, and then the water was just concentrating. So those one, because it was still within the warranty of our contractor, they were able to replace that and add more subgrade material and then flatten that area and replace those pavers. So there were. But then again, there was an intensive monitoring and maintenance for a period of 2 years for those for that project.
Thank you so much. No more questions at this point.
Okay, thank you. So moving on. Now I kind of wanted to add a little bit more or include more projects. This I also work for the city of East Palo Alto, and one of the projects that I work on was again leading the green street infrastructure. This one I have to give credit for this, I guess, graphic with for CSG and City of East Palo Alto. So I started the design for this project, overseeing the design, I mean. So basically this project was a safe route to school project, but it was also improving the roadway conditions, drainage conditions, and it also is a bike route. So basically this project included items such as um, improving crosswalks and bioretentions, as well as permeable paver crosswalks too. And just to highlight, oh, sorry, just to highlight a couple of the you know, integrated project. This is an integrated project because, again, like I said, it was a safe route to school, but it was also like a heavily ponded and flooded area. So we use green infrastructure to address stormwater volume, as also stormwater quality, but then make that into improvement as a safe route to school. So it's a multimodal kind of street improvement, but again, it helps with reducing and slowing off runoff, filtering pollutions, improving drainage, and at the same time, again, like I said, incorporating elements like safe route to school, as well as improve bike trails or bike routes. Oops. And here I am at City of Carmel. So currently we have projects also that we are installing permeable sidewalks, and this one is already installed. This was before me. This is along Devendorf Park. So this is a permeable paver where they have the spacers in between, as you can see in here. And we use also sand. There's sand elements in there, and the what do you call this? The borders are. I mean, we have obviously the borders on using the curb and gutter, but then the three wells also have the borders that we use for this particular one. But for the other project, for the other elements of the upcoming projects that we're using, we are using some band borders like concrete, and then the other ones are just using redwood. What do you call this? A band at the edges. So, what are the site considerations for permeable pavers? The first is we had to hire a geotechnical, engineer to confirm the soil infiltration and subgrade stability. We also had to avoid utility conflicts and maintain setbacks from permanent structures out there in the public right of ways. We also have to make sure we have adequate aggregate storage at the bottom, and if not, we do have uh, overflows, which is to address proper drainage. There is obviously a limitation in steep slopes or high flow areas. And then there's also control sediment issues that we need to deal with to prevent clogging. We also do have to match paver and base design to traffic loads. And the other consideration is also, I guess, the street configuration, whether you're able to really put that in the street. If it was used for traffic calming it was used for green infrastructure, drainage, but also used for traffic calming in one of our projects in Palo Alto. So it has a multiple use or benefits. And this one, just to give an example of another city project, this is one of the pervious concrete installation, and this is the Holloway Green Street project in San Francisco. And then just to give you a little bit, I guess, of way to encourage residents, or I mean even us for the cities, right? One of the programs that I manage in the city of Palo Alto is called the rainwater harvesting program. So it gives incentives to residents and business owners, or other entities to, install these LID, low impact developments. I mean, some of them are rain barrel cisterns, but one of the item that we give rebates is pervious pavement. So those elements, such as, again, pervious concrete or porous asphalt and permeable pavers, we do give a rebate of $1. We used to give a rebate of $1.50 per square foot, and there is a 100 square foot minimum, and the maximum that we used to give was $1,000 per installation. And these are voluntarily done, and because they get incentives, so there's a lot more people who are encouraged to do this. But there was another program that gives more incentive, and that was also with our county. So they get incentive from the city as well as the county. And this is just one way to sort of incentivize people to utilize green infrastructure. I mean, primarily for this particular discussion, pervious pavement. And I think that ends my presentation. So thank you all.
Thank you so much, Shari. So folks, if you have any questions, please submit them through the Q&A function, and both of our presenters are available to answer your questions. We'll give folks a minute to type out their answer or their questions, and we'll answer them. Speak now or forever hold your peace. All right, folks. Well, as a part of this presentation, we do have a question now. How are infiltration rates calculated for each?
I mean, I don't calculate it myself. We do hire a geotechnical to conduct those, like investigation, and they look at the soil permeability and then identify the case, or it's called K, or infiltration rates for us.
Thank you. Anyone else with questions? Oh, yes. I see you used a hybrid system with pavers only in the parking area. How was maintenance?
For the permeable paver,
I
I
believe so.
So yes, so for the permeable paver, they did some sweeping and some vacuuming over the span of 6 months when they did it at the corporation yard. But yes, it was also the same thing when it was already installed in the field. I mean, there's obviously a lot of checkup when after a rainy season, then we kind of look at it. If it's draining, then that means it's still working. I mean, obviously it's not going to capture, like a 20-year flood, right? I think either a 1 year or 2 year flood. So at one point when it's saturated, it will just bypass it. But it's helpful, especially for the first flush, making sure that the contaminants or whatnot goes into that system, but also that we had a bioinfiltration too, or bioretention, so that also helps.
So we have a comment saying we've seen issues with hybrid systems clogging prematurely when AC runs into the pavers.
Um, yes, I think I would say it's the quality of, I guess, when the construction, right, of AC. I mean, they have to roll on, they have to do rolling, right, compact those AC as well. So yes, I mean, some of the times if the quality of the workmanship for AC work is not done right, then it will. But again, that probably is going to be on your maintenance and operations to kind of deal with that. But also after any construction, just making sure that those are done correctly too.
Just like the permeable paver systems or the permeable systems require the maintenance, if the asphalt area isn't maintained as well, I would say that that's going to lead to that issue. So if you're not cleaning the asphalt as good as you're doing your permeable system, it's going to lead to that problem. You set it and forget it with one system, and it's going to affect your second system.
Great, thank you. Any other questions at this point, folks? And as a reminder, this is being recorded and will be posted on our YouTube channel. We have another question. How often do you have to clean them?
It's going to be dependent on the area. You know, in a place like Hollister, I would say every quarter, where it's very windy, very dry. It's all going to be dependent on what it's used for also. But I would say at least a couple times a year would be a good starting point. And it's all that wear and tear is going to dictate that. But a couple times a year, I would say at a minimum.
So like I mentioned, this will be available on the Monterey C YouTube channel, which is at Monterey C, which is Sierra Echo Alpha. And thank you so much to our presenters. Thank you, Chago Ramirez from Granite Rock. Thank you, Shari Carlett from the City of Carmel. And thanks to all of you for joining us today.